Hey everybody, welcome back. Alright, we've been learning how to find derivatives of trigonometric functions and how to apply the chain rule and so forth with those derivatives. And in section 14.2 to start off, we're going to be using the product rule and quotient rule along with trig functions. Alright, and we're going to reintroduce some of those functions back from chapter 7 that we learned to find the derivatives of e to the x and the natural log of x. Alright, well, a few short examples for us to look through in this video. Let's see how we can do. Alright, and the direction simply will be find the derivative of each function. And we're going to begin with this function here. F of x is equal to the natural log of the tangent of x. Alright, now just as we looked at in the first video for this chapter, we've got a composition of two functions where the outside function is the ln of x. Alright, I'm going to write this in colors again. And the inner function is the tangent of x. And we simply have to use the chain rule here. So we'll take the derivative of the outer function and of course multiply it by the derivative of the inner function. Alright, and then just go ahead and simplify the expression. And we had a nice, quick, easy derivative using the chain rule there. Alright, so that wasn't the product rule or quotient rule. It was the chain rule again, as we already did in this chapter, but wanted to introduce the natural log of x along with the trig functions. Alright, next example. Alright, you see the function that we're trying to derive here. And this time the product rule is going to come into play because you see we have e to the 2x and then times the sine of x squared. And remember that whenever you're trying to use the product rule, the way we'd learn that was this. You do the first function times the derivative of the second function plus the second function times the derivative of the first function. 1d2 plus 2d1. Alright, let's go for it. So 1d2, we're going to go ahead and just copy down the first function, 2x, and then we're going to multiply that by the derivative of the second function, which is a composition of two functions, it turns out. Right? We have the sine of x squared. The derivative of the sine part of that is going to give us a cosine of x squared. That was the outer part of that function. And we've got to multiply it by, well, let me make this bracket so this is a little nicer, by the derivative of the inner function 2x. Alright, now we need to do plus the second function, sine of x squared, there we go, times the derivative of the first function. And when we take the derivative of e to the 2x, alright, you got to use the chain rule for that also, right? You're going to get e to the 2x times 2. Alright, now what's left for us here is to clean this mess up a little bit. For this first term right here, we can make that 2x e to the 2x cosine of x squared. Plus, and we can just simply make this second term right there into 2e to the 2x sine of x squared. Alright, and then this next part is helpful sometimes. It doesn't do a whole lot for this particular problem, but you're going to notice that there are some common factors between these two terms. We've got a 2e to the 2x in the first term, and we got a 2e to the 2x in the second term. So we're going to go ahead and factor that out. And for the first term, that leaves us with an x cosine x squared. From the second term, that leaves us with the sine of x squared. Alright, nothing else that you can do with that. Sometimes after you factor out that e to the 2x or something somewhere, you can combine these two expressions, but we're not going to be able to do this time. All right, so that's 2 quick examples down. Questions so far? Make sure you ask them in class tomorrow if so. Let's go ahead and go to one more example, and this one's going to use the quotient rule. So I'll give you a chance to copy that down. All right, and remember the rule we learned for quotients, deriving quotients, was this. Low D high minus high D low over low low. All right, let's put that into action here. Okay, so we're going to do the lower function times the derivative of the higher function to begin. So, lower function being cosine of x, I'll just copy that down. And then the higher function is 1 plus the sine of x, and we're trying to derive that right now. Of course, the derivative of 1 is going to be nothing, and the derivative of sine x is going to be cosine x. So there's our low D high. Minus high D low. So let's copy the high function, 1 plus sine x. And multiply that by the derivative of the lower function. And the derivative of the lower function, cosine x, is going to be negative sine x. And over low, low, so we're going to square the denominator, and that's going to give us cosine squared x. And let's clean this thing up. All right, cosine x times cosine x is cosine squared x. All right, and then see if we can do all this distribution at one time. All right, we're going to have a negative 1 times a negative sine of x, and that's going to give us a plus sine x. Then we'll have a negative 1 times sine x, so negative sine x, times negative sine x again. That'll give us positive sine squared x. All right, then there's one more thing that we're going to want to do with this one. You're going to remember a lot of trigonometric identities that you learned back in your trigonometry days last year. And it's going to happen from time to time where we're going to use one of those Pythagorean identities or reciprocal identities or double angle or half angle identities in order to simplify an expression. And we're not going to go out of our way to do it, but whenever it's possible, we're going to use those things. And I'm saying that now because I hope you notice that in this numerator we've got a cosine squared x plus sine squared x. And of course you know that cosine squared x plus sine squared x is equal to 1. And so we can simplify that expression to this. We can make that numerator 1 plus sine x. And then we'll keep it over cosine squared x. Alright, so those are some examples of using the product rule and the quotient rule along with trigonometric identities. Thanks for watching. See you next time.